Hello again. In this video, I'm going to go over the network diagram and critical path method. So first, we're going to take a look at what a network diagram looks like. So network diagrams are drawn something like this. The way to read these is A is a predecessor of B, meaning A must complete before B may begin. A must be complete before C may begin, so on and so forth. Before K can begin, B, G, and D must all be complete. O cannot begin until L, M, and N are complete, so on and so forth. I use the activity on node. That's what we'll be learning in this class, is activity on node. There's an activity on arrow as well, but we're going to work in activity on node. All right, next we're going to look at part of the data table that you'll be receiving. We need to understand predecessor and successor tasks. Predecessor are the tasks that must be completed before. So you must get bread out of the bag before putting it in the toaster. Therefore, getting the bread out of the bag is the predecessor of toasting. The opposite of predecessor is successor. So toasting is the successor of getting the bread out of the bag. In our example here, task A must be complete before task B can begin. Task A must be complete before C may begin. Task B and C must be complete before D may begin. Task A doesn't have any predecessors, so that can start anytime it wants to. All right, once we have this information, I recommend getting a clean sheet of paper for every problem, and then in one corner, make a fairly small arrow diagram, and we just copy it down first by putting any tasks that don't have predecessors. In this example, A doesn't have any, so we'll put that down. Next, we put down B with an arrow, linking A to B, A to C, and then B and C to D. So go ahead and count these: 1, 2, 3, 4, 1, 2, 3, 4 tasks, 1, 2, 3, 4 arrows, 1, 2, 3, 4 arrows. So the number of arrows should equal the number of predecessors over here, and the number of tasks should equal the number of tasks. These numbers in this example are the same, but that's not a rule that we generally follow. All right, next, the next part of the table we'll look at is the duration. Duration is the amount of time a task takes to complete. So make sure you're working in the same unit. In this class, we generally work in days, but in actual projects, you can work in anything from seconds or fractions of a second down to years. All right. Before we're going to use that information to fill out this table. So this is my preferred format. There are other formats out there, but this is obviously the one that I use. So early start is the earliest a task can possibly start. Duration is the amount of time it takes a task to complete. Early finish is the earliest a task may possibly finish. So it's not possible to start before early start or finish before early finish. A task is just a small unit of work within a project. Late start is the latest a task may possibly start without delaying the completion of a project. So if it starts later than that, it might delay the project, or it will delay the project. Early start and late start might be the same number, or late start might be later than early start. Float or slack, we're just going to call that the spare time. You can allow this to either extend the duration or delay the early start. And late finish is the latest a task may possibly finish without delaying project completion. So same thing. Early finish is the earliest it can possibly finish. Late finish, it may be later than early finish because you may have some slack in there that allows you to get done a little bit later. All right, so we take our arrow diagram, we recopy it using this format, and then we're going to go ahead and fill in some information. So anything without a predecessor gets a 0. Then we take all of our durations from our table, we add those in, and then we go ahead and we gray that out. So we don't need that information anymore. I prefer, again, just to get a blank sheet of paper, copy all of this on, and then I can ignore that and work completely from my piece of paper. So then we work our way through. The math is quite simple. Early start plus duration equals early finish. 0 plus 2 equals 2. Then the early finish of the predecessor equals the early start. So in this example, we only have one predecessor, so we just go ahead and we pull that 2 forward for both tasks. Then our early start plus our duration equals our early finish. So we have 2 plus 3 is 5, 2 plus 2 is 4. Now the early start is the latest of the early finish. Because we have 2, we have to look at which one is the latest. So 5 is later than 4. Therefore, this won't be able to begin until day 4. A task cannot start until all preceding tasks are complete. So you're taking the latest of all of those. Then early start plus duration equals early finish. 5 plus 2 equals 7. Our project duration is 7 days. So we've just completed our forward pass. Forward pass tells us the total project duration as determined by the completion of the last task. So forward pass is the top of the tables and it gives us the project duration. Backward pass fills in the bottom and determines our critical path. So we'll work through that next. So late finish is the latest a task can complete without lengthening the duration of the project or extending the duration, delaying the completion, however you want to word that. So early finish of the latest completing task is the late finish. So any task with no successor tasks will have the same or the latest late finish. So if we have E down here that also doesn't have any tasks following it, it would also get 7. Late finish minus early finish equals slack. 7 minus 7 is 0. Early start plus slack equals our late start. 5 from our early start plus our 0 gives us 5. The late finish is the earliest of the late start. In this example, we only have one late start, so we just pull the 5 backward. There we go. Late finish minus early finish is the slack. So we have 5 minus 5 equals 0. 5 minus 4 equals 1, so we have 1 day of slack in task C. Early start plus our slack equals our late start, so 2 plus 0 equals 2. 2 plus 1 equals 3. There you go. So now the late finish is the earliest of late start. So if we have our choice between finishing on day 2 or day 3, we have to finish by day 2, otherwise we're delaying B, which is going to extend the duration of the project. Again, late finish minus early finish equals our slack. Early start plus slack equals our late start. There we go. So our backwards path is complete. Our critical path is all tasks with 0 slack. We can double check that as long as you don't have parallel critical paths. So we just have one critical path through here. The duration, A of 2, B of 3, D of 2 equals 7. That's our total project duration. Now, if C were also on the critical path, if C's duration was 3, then all those would add up to 10. That wouldn't be correct, but if you have one single path through, that will hold true. So what is slack? Slack is the number of periods that a task may start late or be delayed or a combination of the two. So task C may start on day 3 or take a duration of 3 days without affecting our project duration. Or it might be a combination, so maybe it starts halfway into day 2 and it takes 2.5 days to complete the duration. That's all I've got for this. Let me know if you have questions. Have a great day.